Welcome to this deep dive. Today we're heading to Mars. Well, not literally, but we're diving into some fascinating new research from NASA's Curiosity rover.
Always exciting.
You bet. You've sent over some articles about Curiosity's latest discoveries.
I have. It's pretty groundbreaking stuff.
And we're going to break down what this all means for, the big question life on the red planet. So,
Yeah.
what's grabbing your attention about these findings? What's got you hooked?
It's all about the rocks.
Rocks!
Yeah. But not just any rocks. Curiosity is analyzing Martian rocks, specifically carbonates. They're like little time capsules, holding secrets from Mars's past.
Time capsules. Okay, I'm intrigued. How so?
These carbonates hold clues to Mars's past climates, and that tells us something about, well, habitability. Could Mars have supported life?
Ah, the big question. Okay, let's unpack this whole rock analysis thing. One of the articles mentioned Curiosity using its SAM and TLS instruments. Sounds pretty high tech.
It is, but also really cool.
So what can we learn from these, what did you call them? Space-baked rocks?
Space-baked, I like that. So Sam, that's short for sample analysis at Mars.
Catchy.
Right. It's basically this mini chemistry lab, but on Mars. It heats up rock samples, like really hot,
How hot are we talking?
almost 1,000 degrees Celsius. And that releases these gases that have been trapped inside the rocks for, well, billions of years.
1,000 degrees. Wow.
It's intense.
So these gases, they're like whispers from the past.
Exactly. They tell us about the conditions way back when these rocks first formed.
Okay, I'm getting a little lost in space here. What about the TLS? What does that do?
The TLS, the Tunable Laser Spectrometer. That's our detective tool.
Ooh, a detective. I like it.
It analyzes the light that's absorbed by these gases,
Yeah.
identifies the types of molecules floating around, but the really important part is the isotopic composition.
Isotopic. Say that again?
Isotopic composition. Think of it like a fingerprint. Each element, it has these variations called isotopes.
Yeah.
And the ratio of those isotopes within the carbonates, that tells us what the climate was like back when those rocks were formed.
So like a chemical fingerprint revealing the environment of ancient Mars. Incredible.
Exactly.
What are these fingerprints telling us? Was Mars a tropical paradise?
Not quite a paradise, but the isotopic composition suggests two possible scenarios. One scenario points to, well, cycles of wet and dry periods, extreme evaporation.
Okay, so like imagine vast lakes and rivers, but then they completely dry up and then boom, they reappear.
Exactly. Mars swinging between maybe habitable periods and then harsh dryness.
Wow, that's a dramatic shift. What about the other scenario?
This one's even more extreme in environment with incredibly salty, frigid water.
Like too salty to even swim in.
Way too salty. Think more like a Martian deep freeze. A brine-like ocean, but frozen solid, and way too harsh for most life as we know it.
Okay, so both options paint, well, a very different picture of Mars than, the kind of habitable planet we sometimes imagine. So which scenario is more likely, you think?
That's the million-dollar question. And honestly, both scenarios are supported by other evidence we have about Mars.
So we're back to square one.
Not exactly. The isotopic data from Curiosity, it's a brand new piece of the puzzle.
Okay, so we're getting closer to the truth.
We're getting closer to a clearer image of Mars's past, that's for sure.
I like the sound of that. This feels huge, but one of the articles did mention something like bad news.
Right, and it's important to be careful here, to not jump to conclusions.
What do you mean?
Well, as exciting as all of this is, the findings, they don't directly support the idea of an ancient biosphere, life on Mars's surface, at least not during the time these carbonates formed.
So, no ancient Martians.
We can't say for sure.
Does this mean then game over for finding signs of past life on Mars?
Absolutely not. If anything, this is where the excitement really begins.
How so?
Just because we haven't found evidence of life on the surface at that specific time doesn't mean it wasn't there at other times.
Good point.
Or, and this is a big or, life could have thrived underground beneath the surface.
Where conditions might have been a little more comfortable?
More stable, for sure. It's easy to get caught up in what we see on the surface, but Mars has a whole hidden underground. We're just starting to explore it.
That's a really good point. We are just scratching the surface, so to speak, when it comes to understanding Mars, aren't we?
Absolutely. And every new piece of data, every discovery, whether it confirms what we thought or raises even more questions,
Mm-hmm.
well, that's the beauty of it all, right?
The mystery deepens.
Exactly. It pushes us to keep exploring, keep searching for answers. Who knows what other secrets Mars is hiding, just waiting to be discovered.
It's incredible to think about. Well, thank you so much for this deep dive. It's been truly fascinating. And for our listeners, if today's conversation has sparked your curiosity about life beyond Earth, maybe take a look at extremophiles. These are these incredible organisms thriving in the harshest conditions here on Earth. It makes you wonder, could similar life forms have existed, or maybe even still exist, somewhere in the hidden corners of Mars?